Look at a high-pressure math exam, and you'll almost certainly find a messy pile of square roots and surds waiting to trip you up. By the end of this video, you're going to have the exact step-by-step method to cut through that mess and solve the dreaded find A and B denominator rationalization question. To do this, we only need one tool from your algebra toolkit. Whenever you multiply a minus b by a plus b, you get a squared minus b squared. Combine that single rule with a clear map of how numbers are categorized, and these complex exam questions become a simple matter of following the procedure. Take a look at this diagram showing the entire real number system. Notice how that large outer bounding box immediately splits into two completely separate, non-overlapping teams. We start with natural numbers, expand to include 0 for whole numbers, and add negative values for integers. The outermost shell contains any rational number, any number expressed as a simple fraction, p over q. But look over to the left side. These are the irrational numbers. They refuse to be written as neat fractions. Values like the square root of 3 or the square root of 8 live completely isolated in their own bubble. Identifying a numbers team is vital because it dictates your next algebraic move. If you mistake an irrational root for a rational integer, you'll likely apply the wrong simplification method before you even begin the real calculation. How do you sort them? For decimals, the rule is strict. A rational decimal terminates completely, like 0.25, or falls into a perfectly repeating pattern, like 0.946 recurring. An irrational decimal does neither. It wanders infinitely, never falling into a recognizable pattern. But the most common exam traps aren't decimals. They are square roots of non-perfect squares. This brings us to a classic trick. Examiners love to hide perfect squares under root symbols to see if you're paying attention. If you see the square root of 64, that is actually just the number 8. It's a perfectly rational integer hiding in plain sight. Spotting these imposters early clears the board. You have to know what you're working with before you can simplify a complex fraction. Now, let's tackle that classic 4-mark exam challenge. We need to find the values of a and b in this equation. Our immediate roadblock is on the left side, an irrational expression trapped in the denominator. To fix this, we use the rationalizing factor. We extract the denominator, 2 plus root 3, and flip the middle sign to get 2 minus root 3. Next, we multiply both top and bottom by this new factor. Handling the top means squaring 2 minus root 3. We square the 2 to get 4, subtract twice the product giving 4 root 3, and add the square of root 3. Combined, we have 7 minus 4 root 3. Now for the bottom. a plus b times a minus b becomes a squared minus b squared. 4 minus 3 leaves us with a clean, rational 1. Bring those halves back together. Our starting fraction is just 7 minus 4 root 3. Now we place our clean result directly underneath the right side of the original equation. Comparing them side by side reveals our variables. A corresponds to 7 and b is negative 4. Keep that negative sign attached to the b. Rationalizing the denominator is your required translation tool. It converts an unreadable fraction into a simple expression you can directly compare against algebra. You just took a complex fraction full of irrational roots and systematically broke it down into a clean solved equation. The whole process relies on 3 steps. Identify the messy denominator, flip its sign to create your multiplier, and apply the a squared minus b squared rule to clear the bottom. Now it's your turn. Apply this exact sequence to a new problem. Rationalize root 5 plus root 2 over root 5 minus root 2. Work through the steps, drop your final answer in the comments below, and we'll see you in the next lesson. When you follow the rules of the number system and trust your algebraic toolkit, the hardest problems on the exam become completely predictable.